Yeah, welcome, Moksha. Please proceed with your presentation.
Thank you so much, sir. Good evening to you, sir, and good evening to everyone present today in today's session. We finished our first session on last Sunday, and so I can give a beautiful start to the student lecture series. So today I'll be presenting the second student lecture series on gray codes. So gray codes, just so can you see the slides here properly?
Yes, there is no issue. We can see and hear you quite fine.
Okay, just give me a second, sir. I'm unable to just
If it's easier to do it in the edit mode, you show us there. It's still enough for
yeah,
us.
yeah. I'll do. No, I'll just once I'll stop this share and then reshare it. So thank you. So coming to the agenda on what I'll be covering today. So first I'll be introducing all of this to gray codes. Then I will tell them how gray codes are derived and why are gray codes so important in electronics, even though we have other number systems. And then I will be specifying the applications of a few applications of gray codes. And then I will giving you a case study before I conclude. So coming to the introduction, so breaks is not something absolutely new to all of us because we've already studied break codes. It was one of the basic things that we started to study in our digital systems design. So what exactly are these break codes? So break codes is a binary number system in which two successive values differ by only one bit. So this is actually named after the researcher Frank Gray, who created it in 1953, and that's why we have the name of Gray codes. And now it's become a vital tool in field digital communication and electronics. So it is also called as the reflected binary code or reflected binary, since we have gray codes being derived from the binary codes. So, how these gray codes derived? So here I have mentioned a table of the decimal number system, the binary number system, and the gray codes. So as you can, the decimal number system is nothing but the same old number system that we have been studying since our like schooling. And then comes the binary number system, which most of us know. And now we have studying about the gray codes. So what exactly, how exactly are the gray codes derived from the binary number system? So in the binary number system, towards the right hand side of it is the most significant bit, that is the MSB of the binary integer. So now we have convert it into gray codes by taking the extra of the so the bit that is now in use and the immediate bit to its left, that is in the binary representation. So what exactly and how exactly does this conversion go by? Is like, so for example, take the first binary number that is, sorry, yeah, take the first binary number that is 000 into consideration. Here I've taken 4-bit binary numbers.
Use your mouse to point to where you're talking about. It's easier than for us.
Okay, so I hope
Yes, it's visible
one
to us.
is it. So this, okay, so I was talking about this, that is 000, and this zero in that is actually the most significant bit. So in gray codes for 000, we don't have a conversion, we have the same thing. So it goes the same way for one, but then when we go to two in the decimal two, what happens in gray codes is we in a gray code we know that it's just one bit change. But if you convert 001 to 10010, it becomes a two-bit change since the most significant bit one is also changing, and again the next immediate bit on the left is also changing. So that doesn't act as a gray code. So just because of that, we retain in the most significant bit as it is and change the immediate bit towards its left. So this is how a gray code conversion takes place, which is just one bit change. So just looking into this conversion, we can derive two important characteristics and properties of gray code. One is the single bit change. So this single bit change is an important feature of the gray code, which is why it is applied in so many different electronics, which I'll be speaking later on. The other is the reflection property. So the reflection properties means how it is being reflected from the binary to the gray code. Hence, we also call gray codes as reflected binary codes.
No, 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 no. It is not. It is not related to binary source. See, if you look at the gray code itself, if, for
Mhm.
example, between the first four codes, if you draw a horizontal line after the two codes, no, you will see a mirror image. For example, 0, 1 and then 1, 0, the LSB. Similarly, the
Yeah,
MSB, of course, with the, I mean, the other, there may be an inversion shown, but there is a general reflection. Again, if you draw at the next binary boundary at the 2 power 2 or the fourth, after the fourth line, again, you will see a reflection of the LSB to itself and the next LSB to itself, etc. And then the next bit will be complemented and it will keep moving like that. So the binary code themselves have a mirror behavior within itself.
fine, fine. So this is how the conversion of gray codes take place. So now,
Okay, let's give her some time. Something she'll has to represent.
for glitch in the next.
No problem.
So why exactly we have used gray codes? It's not other number systems like the decimal number systems, the binary number systems, the hexadecimal number systems. But why is there so much importance given to the gray codes? So here are the most important four reasons why I found gray codes to be that prominent in electronics. One being adjacent values differ by only one bit. So how does this help is that, so in gray codes, when consecutive numbers differ by only one bit, it is a crucial in minimizing the errors during transitions. For example, from analog to digital converters, in such cases, when if the bits differ by if there's a difference by multiple bits, that could cause errors or glitches during the transitions. But since gray codes only differ by one bit, that is why we prefer gray codes in such devices. Another reason why gray codes are being used is because of the reduced risk of misinterpretation. So what happens here is because of the only one bit change in the times, its misinterpretation of digital signals is reduced. This property is beneficial in systems where noise or any interference can corrupt the signal, so that because it decreases the likelihood of misreading due to a bit of noise. And you can also be finding its applications in sequential circuits, mainly like such as counters and all, mainly because gray codes prevent invalid states. There are no invalid states that are formed in gray codes, unlike other number systems. For example, we have invalid states in BCD, binary coded decimal. So gray codes prevent such states. So that is why that it finds its application in the sequential circuits. So it also reduces the possibility of transitioning through invalid states, basically. So next is the mechanical simplicity in certain devices. So in mechanical devices, like for example, the rotatory encoders, where physical contacts are used to generate digital signals, gray codes can actually simplify this mechanism. Because when we use gray codes, there's a much higher likelihood of errors caused by contact bounce or mechanical jitter. So because of this only one bit change in gray codes at a time, it makes it easier to determine the correct position. So this is why gray codes are actually this is why we find gray codes application more in these digital communicative, digital electronics.
Superb.
So,
Just one point I want to add to the advantage list.
yes, sir.
You have outlined very well. Two things, 2 points. One point is the additional advantage that is there is because in a gray code there is only one bit changing at any transition time. Okay, the total energy expenditure is fixated to one change. Okay, whereas in a binary code, for example, if the code is moving from FF to back to 00, let's take an 8-bit binary code. So it moves from FF back to 00. There is a massive transition. And similarly, at other points, when you switch from 8 to 9, I mean, there are some places, sorry, 7 to 8, etc. There is massive flipping happening. Some of them are changing to 0. Most bits are changing at those times. So for why that is a bad thing in some circuits, when there is massive amount of transition like that, energy impulse is very high at that time. So it causes energy disturbance. And this, for example, when a rotary drum is transmitting transition count, if there is sudden energy expenditure at multiple bit times, so huge energy surge may be there in transmitting. This you are talking of old, more electrical type of methodologies that were used for rotary encoding, things like that. But still, even in VLSI electronics, if there is a huge count to be transmitted, it is smarter to transmit it in gray code over a huge transmission line, because only one bit is transitioning at any time. There is no surge current required to handle it. This you will study later in VLSI life. These are called there is a particular term used for that, slew. Yeah, so whenever you have multiple bits changing, the power supply will be dragged. Okay, and that creates glitch issues in circuits that can be avoided. But remember, that is point number one, to add on to the advantage. The one other counterpoint is gray code itself is not a substitute for some kind of transmission of codes, etc. Because not always you will get a sequential behavior in all applications. Sometimes when you have to send a message, the data that you need to send will contain all kinds of random variations. So there gray code can't step in and help us, because suddenly you need to jump from some number to some other random number in the sequence, right? So there you don't get advantage. There are other methods there by which we improve things. There are error corrections, things like that involved. That's a separate subject. But gray code is when you have to transmit a sequence of counts one after the other. That is when it's very helpful to switch from binary to gray code, so that single bit transition is assured when we cross from one count to the next count. Okay, this additional information I just want to tell. Please proceed, Moksha.
Thank you so much, sir. So I will be now speaking about the applications. Like there are a few applications that I have derived out of the many numerous applications. So one such application first that I've put is the tower annoyance. So basically, this is not like an electronic application, but like in a smart everyday application. Like it's a mathematical puzzle. Basically, the tower of annoyance is a mathematical puzzle. So it has three sticks and it has numerous disks ranging from the so the disk at the end is actually has a larger diameter, while the disk at the top has smaller diameter. How this mathematical puzzle has to be solved is it's supposed to move only one bit at a time, but you cannot move two bits at a time. But later on, when you arrange the puzzle, it should be in such a way that the disk with the highest diameter should be at the bottom, and the smallest disk should be on. So great. While I was researching on this, I found this very cool because it was written that gray codes can be a solution to solve this. So basically, if one counts in gray codes code, if a bit size is equal to the number of disks in this particular tower, begins at 0 and counts up, then the bit change, each move corresponds to a disk to be moved, where the least significant bit is actually the smallest bit. And this and the most significant bit is the largest one. So this is something like fun application that I found. So I just put it in the PPT so that this was something different from the electronics part. So this is something, well, this is like, it is written like it can be a base before Frank Gray thought about the Grey codes, because this was actually being based on the game that was developed by the French in the late 1883, yeah, somewhere like that. So coming to the electronic applications of Grey codes, basically analog to digital conversion. So this was one of the main reasons why Frank Gray was famous for inventing the Grey codes. So here, Frank Gray actually discovered or invented the gray codes to convert these analog signals to reflected binary codes using a vacuum-based apparatus. So this is where I'll be speaking on another application of analog to digital signal conversion in a case study next. So I won't stress on that much out here. Then we have position encoders and also Boolean circuit minimization. So Boolean circuit minimization, I'm aware that all of us know, because the one and only K map or the Kernow maps that we have learned till now uses the gray code. So that is where we discovered gray code. So that helps in minimizing the circuit. So basically minimizing the expression of the circuit. So then we also have gray codes being used in communication, because as Sir told earlier, the transition, it helps in the transition because of only and reduces the error because of only one bit change. So this one bit change is a very mm, beautiful property of the gray codes, because it helps in reducing the errors, and also it can operate this clock between clock domains. So these clock domains, it can actually operate between a different clock frequencies. So that is why gray codes are actually used in this communication.
Superb,
So,
superb. Actually, just go back to the slide. Go, superb.
okay, sir.
One additional observation. You were right
Okay.
in saying about Boolean circuit minimization. One other
Hmm.
application where, for example, have you guys studied automata theory yet?
Yes, sir.
Yes. Is
No,
that a
we haven't.
yes?
No, we haven't studied.
You haven't. So when you study automata theory as a subject, I don't know, of course, as part of electronics, it will come, or maybe the computer science students in this team might definitely encounter automata theory. There is a state machine problem solving and all those things that will be encountered there. So there are many state machine. There are many different techniques described for assigning state numbers to the states that you design in your state machine. So state A, B, C, D, etc. For example, one basic way in which you go is blindly assign binary codes. Say state A is 0, state B is 1, state C is 2, like that, without being too thoughtful about it. You assign some numbers and go ahead and design your corner maps of next state and output and all that based on that. So that's one method. The problem with and then the another method is called one hot coding, where you say you if there are 8 states, you keep as many as 8 bits of states and say 00001 is state A, 00010 is state B, 00100 is state C. One hot, only one bit will be hot at a time. So that's one other coding. There is some advantage to using such coding if it is a finite size state machine, not some very large state machine. And one of the more attractive state coding is called gray code state assignment, where you assign gray codes for the state movements. And even if there are different branches, you discover such gray codes that you can survive with one bit transition through such branch loops also. So that is when actually you explore the bigger aspects of how to how to have two different future gray codes that are still meeting the gray code tenet, etc., things like that. You will have to expand the gray code size to meet that multi-branch requirement. Anyway, once you assign with that method, then the advantage is any state transition is having only one state bit changing, and this has a massive energy saving implication on the next state determination, because all your next state cloud, which is a huge amount of logic gates, is seeing only one signal change, the state, one bit of the signal change. So there is no glitch or intermediate output from any of the gates. they actually end up producing one clean next state transition with the lowest energy, and that way it will also work fastest through the next state discovery. So not only you will have a high performance circuit, you will have a low energy circuit. So it's a huge advantage to discover binary instead of binary or some other random number coding, to see if you can do mostly gray coding. Sometimes you may not discover the correct gray code branches. That mostly if you can do gray coding so that most state transitions are covered through gray codes, you certainly improve the circuit. Okay, this is a VLSI engineer I'm talking. All you have mentioned is all perfect. Thank you.
So thank you. And so now I have a case study of a digital thermometer with gray code ADC. ADC is nothing but analog to digital converter. So basically, imagine you're designing a digital thermometer that measures the temperature using a thermistor. So we know that the output thermistor varies the temperature. So now we need to convert this very analog signal into the digital format so that we can process it and then display the same. So, like any design, obviously, since it's a thermometer, we need a sensor interface. So, the analog output of the thermostat is connected to the input of the analog to digital converter. Now, we have the analog to digital conversion process where exactly we have the gray codes playing a huge role. So, the analog voltage from the thermistor is actually implied as the input to the analog to digital converter. So this now converts this analog voltage into a digital value using gray codes, encoding by using the gray codes. So this digital value is then processed by the microcontroller as the last stage to calculate the temperature. So here the advantages of using the gray code is reduces the error sensitivity. So since gray codes can ensure that only one bit can change at a time, so during this conversion process, it reduces the sensitivity of errors caused by noise or any fluctuations in this analog signal. As earlier mentioned, it is a smoother transition. So since as edges and gray code values differ just by only one bit, transitions between digital values are actually smoother compared to the traditional binary encoding. So this is actually an important factor for accurate temperature measurement, especially in applications where precise readings are required. And also, this also gives compatibility of sequential circuits. Since it's are well suited for the use in sequential circuits, it may be present in a ADC or in a microcontroller for controlling the conversion process and data processing. So in this case study, we can see how gray codes are being utilized in an analog to digital converter for a digital thermometer application. So by encoding the analog signal into digital format with gray codes, we can have reliable, precise temperature measurements. So even in the presence of noise or sensor outputs, there is no error sensitivity will be less because of the one bit changes gray codes. So this unique property of the gray codes makes it an excellent choice for applications where smooth transitions and error tolerance are essential, such as analog to digital conversion in digital thermometer. So this is why I've used a digital thermometer to show how the gray codes help in the conversion of analog to digital signals. So coming to the
Yeah,
conclusion
Moksha, one
of
one point. That's a good example. Only thing we have to remember is that it is, see, the example she has picked is a slow transitioning data environment. You are unlikely to encounter sharp temperature transitions. It will be progressive. So the sampling period will be so fast that you will only capture at a maximum one transition of the thermistor value being translated into some kind of digital number change. Okay. So because of this application is ideal because the transition is not so quick that you will jump many codes. Likely you will be changing from a given gray code to its next gray code, etc. for subsequent reading. So that's why it is applicable there. If you are having very fast transitioning high speed ADC, there is a different requirement there. But this works for the thermistor temperature measurement type of environment due to the sluggish nature of changes that will occur. Yes.
yes, sir. Sir. So coming to conclusion, so we did see on how gray codes play a very crucial role in digital electronics due to their unique property and advantages. That is the single bit change and also the reflective property. Then the gray codes is characteristic of having adjustment value differing by just one. So this helps in improving the signal integrity, making them less susceptible and also to noise and interference, reducing the error to occur and also scale the transitions. So because of this, we can apply gray codes in various fields like in encoders, decoders, DACs, ADCs, and also to not just to detect the error, but also to correct the error in communication systems because of one bit change. It's easily detected. So thus, it makes them a valuable tool in modern electronics design. So this is why we have been using gray codes this significantly in electronics. So with this, I would like to conclude. I hope I have whatever I wanted to present. I was clear enough, and I you all could understand. So I'm very open to questions and to feedback. If anyone has any doubts or something, you can ask me. I'll try to answer, or either if I don't answer or like I don't know it correctly, I can just get back to you all. So anyone have any questions?
Guys, please raise any not, no question is silly, so please don't worry about that. Anyway, Moksha, you have done an excellent job. Of course, Moksha, right in the beginning, you told me you have limited it to a scope to a basic level so that we don't try to overdo the things. There are a lot more to explore. I understand that. You've done a good job of covering the basics. Lot
Okay.
of further, for example, additional subjects from a digital designer viewpoint would be how to convert binary to gray, how to convert gray to binary, how to encode counters natively to move in gray code without needing binary as an intermediate transition. All those kind of potentially Verilog snippets which show all that would be of utility to add as additional, for example, gray code 2 type of presentation. Okay. And things like that potentially. It's a little deeper than more matter is available. You have done an excellent job in a short time in the midst of your post-exam schedule to come up with a good basic presentation of this. I thank you for that. Guys, please ask your questions now. And also, Professor is still, Dr. Shyamala is still there. Maybe she has a few words to say. She was right through the presentation.
Hello. Sir, first thing I would like to congratulate Moksha. She has done a very good job of presenting.
Thank you,
Good, well done, Moksha. Your
Thank you.
presentation skills were very good. You have tried to, at least the basic part of gray code, I think you have covered, as Sir rightly said. But as now, as Sir has already mentioned, you people can understand that there are so many things to explore further, isn't it? So you can keep up this good work and continue studying, continue exploring. Other than, I mean, like just not stick on to a curriculum. Doing these things will definitely upskill you further, isn't it, sir?
Absolutely, ma'am. Thanks for your encouraging words. I appreciate that. I'm glad that you students, you should appreciate having such a committed teacher as Dr. Shyamala, who
No, sir, it's my
participates, spends
duty.
her time to also join with us, and I appreciate that. I think Doctor also was there for a while.
Yes,
Sir also was there, but I think he had other responsibilities. So after the
yeah, sir.
presentation, he stepped out. So I did observe Dr. Rajendra sir also had
Yeah,
joined.
he was there, sir. He was
Yeah,
there.
yeah.
I
So that
missed
is.
out on Sahitya's presentation due to some
No, there is
commitment.
a
So,
recording.
but
So when you
yeah,
have time, you can, quickly take a look
yeah,
to,
surely,
so that
surely,
you
sir.
appreciate her work also. Yeah.
Yeah, we are proud, sir. Our students, when they come and do something like this, we are very happy. We would like to encourage the other students also to come forward
Yes,
and
yes. In fact,
continue
what
this
I will
together.
do now is today, especially after you put in your word, Professor, more students have joined. I thank you for your
No, no.
recommendation, firm recommendation, let me say.
No, sir. I would like more. Actually, this was not the number I expected. I wanted further because,
No. This
see,
is Moksha is a lot more happy than how we managed earlier. Her own
No, sir.
sister
As
is
we proceed, probably
Sahitya has
we will
joined
have
it.
more people coming onto the platform,
Yeah.
and maybe we can keep up the good work.
Yes,
Continue.
yes. So I will publish the next lot of to propose the next lot of subjects. Okay.
Yes, sir.
Then
Yes, sir.
people can start listing their own names under the subjects. So first come first serve basis. Let's be
Yeah, that's right.
enthusiastic. And remember, you are the one benefiting from it. There is an effort of it. The effort is required to benefit also. So please do come forward and enlist yourself for the subjects that I'm going to propose. Dr. Shyamala, if you have some subjects in mind, you can also share it in the WhatsApp group over there.
Yeah, sure,
Okay.
sir. Sure.
So
Sure,
let
sir.
me come up with the next lot of subjects and then pick some students. The students pick themselves in for that and start participating. And I promise you from my side to encourage you guys, all of you who volunteer and deliver good presentations will benefit from it with a small useful gift from my end. Okay. So that's something that I
That is
promise.
a very good gesture from your side, sir. Thank you so much on
Most
behalf of the students.
Okay. All right. So any questions, guys? Otherwise, students are not listening is what I will conclude if you don't have questions. I'm going to call some names, I think. So first, let me call Sahitya herself. Sahitya, please, if you have any,
Hello, sir.
you understood everything?
Yeah, pretty much, sir. It was the basics of grade course.
Okay.
So
First question
I
for you
didn't
then.
have any.
First question, since you understood
Oh, sir,
everything. First question. So can you have a gray code set which is not 2 power n? Is the question to you. Say like you will come up with a gray code set that rotates around
yeah,
4 states, 8 states, 16 states definitely. But can you
yeah.
have a 5-state gray code? Please explore that and come up with an answer for us in the WhatsApp group.
Okay, sure,
That
sir.
means
I
it
will.
has to rotate back to
Yeah,
the original state with only one
yeah.
transition. Okay.
Okay, sir.
So are
Yes,
there
sir. I'll do.
non 2 power n rotations possible? Okay. You have to
Yes, sir.
explore that. Okay.
Okay. Yeah.
Anybody else has questions? They're all running away. Okay. I think Moksha, everybody has understood. So I have thrown a challenge for your sister because she didn't ask a question of you. So thank you very much, Moksha. All the best.
Thank you so much, sir, and thank you for giving us the opportunity to present. Thank you, sir.
Most welcome. Thank you. Bye,
Thank
everyone.
you, sir.
Bye.
Thank you.